Hi, welcome to the STEAM Club. I'm Marcy, and today we're doing some amazing paper tricks using some math concepts. We have 4 different activities. One, we're going to see, can we step through a piece of paper? The second activity is to make some Mobius strips like this and do some activities. Then we're going to make a straw flyer that's using a drinking straw to make an airplane. And our fourth activity is to take a dollar bill and some paper clips and do some tricks with those. Let's get started. You can continue to watch this video over on our SCCLD Facebook page. You can watch it at any time. You may have to scroll down because we put lots of activities on that Facebook page. You can also use the second link to watch any of our Kids STEAM Club videos that we've made in the past year. So, how can you take a regular piece of paper and walk through it? If I cut a hole here, I would not be able to fit through that hole, but maybe you could. Well, let's see how we can do it. We're going to use paper, pencil, ruler, scissors, tape, and markers for our first 2 activities. Take a piece of paper, just a regular piece, 8.5 by 11, and we're first going to fold it hamburger style. That's this way, where you're taking the long edge and folding it up. Then we're going to be marking our paper. We want the fold to be here, closest to you, and the first line is going to be about an inch from this edge. And it starts at the fold, but it stops here. We're going to have a little gap. We're going to have about an inch gap from the top. Then we're going to do the same thing on the other side. As you start here at the fold and draw your line up, an inch from this edge and an inch from this edge. The third line is going to be between these 2 lines. It's going to be about 1/2 inch from the fold. Then we're going to take those 3 lines that we just drew, and we're going to cut on those lines. So you stop here at the 2 points. I did these 2 cuts first because it's easier then to get your scissors in to make this cut. This little extra piece can be put in recycling. We don't need that piece any longer. Then we're going to make some other lines, and they're going to start from every other one. Will start from one edge or the other. So starting at the bottom, I see that we have 3 lines. So I folded my paper slightly in half so I knew where this next middle line was going to go. Then I drew my other 2 lines. I drew this line because it's halfway between this middle one and the one I already cut. And again, I'm stopping 1 inch from the top here. I'm starting here where we cut that piece out, but I'm stopping an inch from the top. And then I drew this line because it's halfway between here and here. The measurements aren't important. Then at the top, we have 4 other lines. They start here, they go here, but they're another inch from the edge. They stop here for a gap of an inch. So once you have these lines that start here, you could put these lines in because they're halfway through. So just use this as a guide, and you could draw more or less lines. This works with more or less as well. So now we're going to cut those lines again, making sure that we don't cut all the way through. And this is kind of flimsy because we're using kind of flimsy paper. So once you have a cut and you start unfolding it, be careful here at where the cuts end, because that's the most flimsy part of it. So carefully pull it apart. And can you step through it now? Is it possible to step through it? Even I think I could step through this. By cutting this continuous maze, we're making a hole in the middle of the paper that's bigger than the paper itself. And if you remember some math and parameters, that's where you add up all the edge of the outside. So if we add up all our outside, we have 8.5 by 11 by 8.5 and 11, we get a parameter of 39 inches. But once we put that zigzag lines in, we're not just counting that as the outside, but we're also counting all these other lines that we made. That's why this works, is we're making a larger perimeter so that we can walk through it. Here's an extra challenge. We saw how we could make this if we use a regular piece of paper. What if you use an index card that's a lot smaller? An index card is stronger, so you can put those lines a lot closer together. And you can draw a lot more lines in that. So experiment using the same kind of model as we had before, where we're leaving gaps at the top and bottom so that we're not cutting all the way through the card, and see if you can make a loop that's big enough for you to walk through. We're on to our next challenge, and this is making some strips. We're going to cut several pieces of paper. We want this to be about 2 inches. It works if it's smaller than 2 inches, but we're going to be cutting in the middle, and so we want to have a lot of room for us to do this project. So I made strips that were 2.5 by 11 inches, but then I taped them together. I had an overlap, so we overlap it. It's not just edge to edge, but we overlap it, and make sure to put a piece of tape here and a fairly big piece of tape, not just a little dab in the middle, but put a whole big piece of tape on both sides of the paper. And the first thing we're going to do is make a loop. So here we're going to put another piece of tape and another piece of tape to make a circle or a loop. And once you get that, you're going to take a marker and mark halfway down the middle of this with one color. On the outside, mark it all the way around with one color. And in the inside, use a different marker, and along the middle, mark it in the inside with a different color. And now we're going to cut this loop. So what happens if we cut along that line? An easy way to get your cut started is if you take your loop and you do a little tuck, you do a little fold here, and then you take your scissors and you cut there. That gives you enough room to get your scissors in and cut along the line. So we're not going to cut all the way down here using the scissors. We're just making a little tuck here so that we can then open it up and get our scissors in and cut along the line, just like the picture here. So what happens if we cut along that line? What do you think? We're probably going to get 2 circles. But now what we're going to do is we have something that's a little twist. We're going to make our loop here, but before we make a circle, we are going to do a twist. So I'm just going to twist it over like this once, and then we tape it here and tape it in the inside, and this is called a Mobius strip. So once you have that taped, again, use your marker and in the middle, start a line and go all the way around until you get back get back to the end of that line where you started. And now we're going to cut that Mobius strip again along that line. What do you think is going to happen? Are we going to end up with the two circles like we did before? Let's see. Well, this is our first experiment with the two circles, but when we add that twist to it, we just get one big circle that has a twist when we cut it. How could that be? Again, when we added that little twist, that's called a Mobius strip. And a Mobius strip only has one side. How can that be? Think about when you took this circle and you use one marker to go around the outside and one marker to go around the inside, and you saw that there were two sides. But when you put the same line on the Mobius strip, you didn't have an inside. It looked like this was going to be the inside, but when you drew your line, it was one continuous line. That's how come we say it has one side. Let's do some more experiments. First we have a fun fact. Do you ever see a Mobius strip in real life? And the answer is yes. There are some conveyor belts that have a Mobius strip in them. And the reason why is that this belt lasts longer. There's not more wear and tear on the outside or inside because all the surfaces are one surface, and so it gets the same wear and tear on the belt. On to our next Mobius strip project. Let's make the same Mobius strip where we have one twist and tape it. This time we are going to draw a line about a third of the way in along here and draw it until you come back to the end. And now we're going to cut along that line again. But before we do, make your predictions. What kind of size what's going to happen? Are we going to have some circles? What's going to happen? Let's see. When we cut that 1/3 from the edge, we end up with one small circle and one large circle. Did you predict that? I didn't. Now we're going to do something similar to the second one we did. We're going to make a Mobius strip with two twists. So I'm starting out with one twist. I'm holding my paper again, so then I'm coming and making a second twist. And putting tape down on the inside and outside. And this time we're going to put a line down the middle. And we're going to cut down that line in the middle. Do you have any predictions of what kind of shapes you might get? Let's see. This time we ended up with two medium circles. I would not have guessed. Well, let's try it with 3 twists. So I'm starting out with 1 twist, 2 twists, 3 twists, and tape it down. And then in the middle, make your line again. That will be where you cut. What predictions? What do you think you'll end up with? Did you think you would end up with one small circle and then one really twisty large circle? Here's one last one we're going to do. This one's going to be a little different. This one's a big cross where we have a small section here, and then we can even add on pieces here to make a really long section. And before we put it together, this time we're going to draw our lines before we put it together. So on the small portion in the middle, draw a line. On the long leg, put 2 rows of dashed lines in it. So about a third of the way you put one row of dashed lines, and then a third of the way, you put another row of dashed lines. How we're going to put it together is, on the small section, we're not going to make any kind of twist. It's just going to be a circle. So put that together in tape. Then we're going to make one twist on the long side. So that's going to be the Mobius strip. And tape. We're going to cut both sections, but it's very important that you cut the long section first. So if you cut the first section first, the smaller section, you just end up with two pieces of things that will come apart. But cut along this 1/3 line and this other line first, and then cut on the smaller section, the solid line. Any predictions of what you might get? This time you end up with a large square or triangle and a small circle. Oh my goodness. So those are different experiments with Mobius strips, and you can think of others. You could go online and pick up some other ways of making Mobius strips and doing some other experiments, or you can just try some on your own. Let's go make a straw flyer next. So what we need are some strips of paper. I took regular 8.5 by 11 paper, and on the long side, I cut strips of 1 inch by 11 inches. So just cut several strips. On a second piece of paper, instead of going the long way, I went now the narrow way, and so you can cut pieces that are 1/2 inch by 8.5. Those are rough estimates, so if you have different measurements, that's okay. And so, but we want a couple different sizes. And then gather some straws and some tape. First, you put together those pieces of paper to make some circles, some loops, and attach them to the straw. Attach them anywhere you want on the straw. In fact, you can make several of these flyers so you can see if there's different placements of the loops, if they make the flyer fly differently. You can attach, I just attached a small one and a large one, and I attached them kind of together, not close together, but the same direction, but you can do it a different way. You might put one on the bottom. Now what we're going to do is throw these like a spear, and see if it makes a difference if you have if you're using a large and small one, if it makes a difference which direction you're throwing, if it makes a difference if this is in front, the smaller one in front, or the larger one. You can compare when you throw this to throwing a regular straw. It doesn't make any kind of difference at all. Does it make a difference the position of this? So have fun with this. And here's a little science behind why this works. So each loop is really a circular wing. And in fact, if you cut it right here, you would see that it would be just a flat wing. And the flyer works because air moves quicker over the top of the wing than it does underneath it. And so then there's lift that's created. And that's the same thing for a regular wing, is the airflow goes faster over the top and slower on the bottom, which causes lift. On to our fourth experiment. This one, you need a paper bill, a dollar bill, or just cut something out that size if you can't find a bill around, and a couple of paper clips. So we're going to make an S shape. So that's just kind of basically taking your bill and folding it in thirds. And we have a special way to attach our paper clips. So the first paper clip is going to go here. We have the bottom edge and we have the middle. Those are layers. And I'm just going to put the paper clip right in there. It's not going to attach to this upper edge. It's going to attach to the lower and middle. Our next paper clip is going more in the middle. It's going to closer to the fold. It's going to attach to the middle piece and the top, but it's not attaching to the bottom. The paper clips aren't touching each other. There's some distance between them. There's like a half an inch away from each other. And that's how we're setting this up. Is our first paper clip and our second paper clip. Now what we're going to do is we're going to pull the two ends of our bill very quickly and see what happens. What happened to yours? Well, on mine, it flew across the room, so I don't have it so I can pick it up. But my paper clips did attach to each other. They just didn't fall separately. They hooked together. And why did that happen? Well, it's called a transfer of curves. We started out with our bill being an S shape, and we opened it up and we transferred that S shape to the paper clips. So taking this in a little slow motion, you can see the paper clips coming closer together. And when they actually start touching each other, when we are eliminating that S shape in the dollar bill, then the paper clips hook onto each other. You can try this in slow motion. It doesn't always work, though. It can be a little too slow if you take this and do it really slow motion. But it almost always works when you do it quickly if it's set up correctly. Well, we hope you enjoyed these activities. And where do you find more activities such as this? Well, here's a couple of books that we have in the library. One's called STEAM Lab for Kids. Another is Paper Folding Fun. And another called Magic Up Your Sleeve. So we recommend that you check out some of these books if you find this fun. I want to thank you for joining the STEAM Club today. I wanted to remind you that every other week there's STEAM Club or Art Club on Tuesdays at 3 o'clock. And we're running these programs until the end of July. So we hope you continue watching. Thank you for joining us. Bye.